Vichaar Vedh lecture series supported by Fomento. Damodar Krishna Vedlekar Memorial Lecture. Dr. Rajat Talak. Topic: Goa, a place to do science and technology. Dr. Rajat Talak, who studied in Mahila and Nutan English High School and Sri Damodar Higher Secondary School, Margao, Goa, is now an assistant professor at the National University of Singapore and leads the Perceptica Robotics Lab. After completing bachelor's degree in Electronics and Communications Engineering from the National Institute of Technology, Surathkal, he completed his master's with a gold medal from the Indian Institute of Science, Bangalore. Subsequently, he went on to MIT, USA and completed his PhD. Dr. Talak's research has received international recognition. He is a recipient of the ACM Mobihope Best Paper Award. He worked as a research scientist at MIT before moving to Singapore. He works on robotics and AI, focusing on perception and mapping for autonomous systems. Rajat also has a keen interest in promoting science and technology development and is of the strong opinion that all developing countries in the Indian subcontinent and Southeast Asia should be heavily investing in it.
So I want to start from zero. Zero the number. We all know that it was invented in India. People take a lot of pride in it. Kahaniyan chalta, we heard a lot of stories. Some of them are good, and some of them are quite funny and ridiculous. And one of the stories that I've heard on the ridiculous side is that there was some rishi who sat in a cave meditating.
Can you get the voice right?
So, so the funny story that I heard was that there was a rishi sitting in a cave meditating, and zero just appeared to him. And when such stories get propagated, it bothers you because it's a very useful invention, it's a very practical invention, and there is a nice story behind it. But such things get propagated. So let me tell you today what the invention of zero was and what exactly it did. So zero is about writing numbers, right? 1, 2, 3, 4, 5, 6. How do we write it? How do we want to write it? So these are two number systems. All of us have seen this. One of them is Indian, the other one is Roman. It's not because Roman and Indian, that's not the point of this. That's not the reason I'm showing this. The reason I'm showing this is the two number systems write numbers in two different ways. And one of them uses zero, the other one doesn't. So look at the Indian number system. Okay? 1, 2, 3. So for each new number, you're creating a new symbol, ignoring akar. And that goes from 1 to 9. But how do you write 10 in both of these? So for 10, the Indian number system, you don't invent a new symbol. You write it as 1 and 0. You know 1 and 0 already exist, right? But for the 10 in the Roman numeral, you invent a new symbol. And this seems like very simple and because but the invention is here. The moment you write it this way, after 9 you write 10 as 1 and 0, and after 99 you write 100 as 1, 0, 0. You can do this. You can do addition. Suppose you want to add 105 with 24. Right? You have a nice algorithm. 5 and 4 is 9. My 0 plus 2 is 2, and if there is a carry over, you know the algorithm. But if you write Roman numerals, which is a number system that doesn't have 0, right? It becomes harder to add. There is an algorithm, but it's very complicated. And the really interesting part is whatever algorithm that we use, 4 plus 5 is no, and then just that you can do this. it's not just adding extra parts and 24s, but you can add a very large number with another large number using the same algorithm. This you couldn't do with Roman numerals that didn't have 0. And this was the invention of 0. So once you had 0, and that is you would write 10 as 1 and 0 and not doing akar, or 100 as, after 99, 100 as 100 as not doing akar, you could do this. We all learned this in school. So that was the invention of 0. It's a simple trick that of writing 10 as not moving akar but 10 did allow you to do this. So let's move to so this is one thing, one story I told. Second story. Kaka gagana, chasha jajanya, tata dadanya, tata dadanya, kaka gagana, magisha. I mean, yara lava shasa, rakshadnya. But notice one thing when you do this. Avaz panchayat, see which part of your vocal cord and mouth you use to pronounce this. Right? Ko, use middle of the throat. Right? Ch comes hamma. T, ani fude. T, taja fude. P, on your lips. So, spoken language came first. And then came written language. So at some point, someone wrote down all the alphabets, but someone clever had the idea that let's organize all the letters in a way of how they are pronounced. So if you go right, you can actually trace. And then if you do yara lava, it starts at the tip of your tongue, and you have to roll your tongue as you proceed. Yara lava shasna. Why is this useful? The moment you write it this way, you can distinguish between sounds. So you can teach children to distinguish between sounds much better. Ta and tha. Suppose it was in any other order, right? It's a ka, ja, da, ta, tha, ba, fa, ba. Then ta and tha, you would have been able to distinguish ta and tha, or ta and ta, tha. And this is what happens with languages that don't have this. Very few languages have this. And those are Thailand, then there is in Korea, and some more countries. Most of them are likely Indian. So this was another invention, so to say. Just organize letters in a way of where they are articulated, and then that helps. Similar organization happened when Charles Darwin, when he was doing his voyages. So what he did, he was interested in looking at all plants and animals and rocks. What different kinds of rocks and plants and animals exist, and let's classify them. And he tried to organize it. But in his voyage, this is between 1831 and 36, right? He observed that there's some particular kind of, there's one kind of bird, finches mandataka, and it's the same bird on different islands, but on different islands they have different size beak. It's very size, same bird, and the size of the beak matches with the kind of food they eat on that island. Right? So from that he concluded living organisms are capable of changing physical attributes with multiple generations. So the birds might have gone to different islands, and then they changed physical attributes over generations to suit that local environment. They evolved. And if this observation means that probably over a longer time horizon, all of us evolved, all living organisms evolved with small such changes, small such adaptations. And that was the theory of evolution. So, what does this mean? So, 3 examples. In the inventions of 0, someone invented a clever trick of writing 10 as 1 and 0. And you can do addition, multiplication, division of very large numbers. In our letters, someone had a clever idea that let's organize them in a way of place of articulation. and that may help children learn and distinguish between sounds better. In Charles Darwin's case, he saw the same kind of bird had different physical attributes, leading him to propose theory of evolution. Such attention to detail, organization, curiosity, and drive towards discovery has been applied to make much advances in science and technology. So someone was looking at how we fight bacteria, how bacteria fight viral infections. Bacteria don't get viral infections. There's some observations on those regards. And what they observed was the DNA of the bacteria kept changing. And further investigations led to this technology called CRISPR, which is today used to edit genes. So you can edit and alter DNA using this CRISPR technology. Another one is graphene. So graphene is basically a single atom layer thing of carbon. It's a very flat thin sheet. Thickness is the size of one atom. It's transparent, it's flexible, and it's a very good conductor of electricity. But what a team just doing Friday night, just clear moon experiment they were doing, what they found was you can use scotch tape, cello tape, to stick to graphite and peel off graphene. And they developed a procedure to do it. That led to Nobel Prize, but that graphene is today used in everybody's cell phones and computer displays. Now this progress in science innovation, from zero to letters to Charles Darwin to graphene, this has accelerated over the last 3 centuries. And I made a list, I want to read out to you so that you appreciate the pace of these discoveries. So 18th century, this 1700 to 1799, 18th century. We discovered that lightning, that is electrical. We discovered oxygen, hydrogen, nitrogen as new elements. Law of conservation of mass was the basis of chemistry. We invented, in this 18th century, general anesthesia, mechanized cotton spinning machine, first artificial refrigeration, steamboat, first manned hot air balloon which you could fly, hydraulic press, paper machine, and battery. This is for 100 years. The next 100 years, we discovered electromagnetism, law of conservation of energy, discovered that plants are made of cells. We invented internal combustion engine, Morse code, reinforced concrete, man-made plastic, first synthetic dye, first rechargeable battery, carbon fibers, dynamite, metal detector, Alexander Bell telephone, phonograph, and incandescent light bulb. This was 100 years. Next 50 years, that's from 1900 to 1950, first 50 years of the last century. We had television, typewriter, radio, microwave oven, frozen food, vacuum cleaner, modern refrigerator, air conditioner, color photography, synchronized sound and film, 35mm camera, magnetic tape recorder, first programmable computer, first synthetic fiber, first powered, controlled, sustained flight, Wright brothers, assembly line for manufacturing, diesel electric locomotive, jet engine, penicillin, blood transfusion, quartz clock, liquid fuel rockets, nuclear reactor, nuclear fission, atom bomb. 50 years. First 50 years of last century. The next 40 years, that is 1950 to 1990. You have integrated circuits, microprocessor, World Wide Web, internet, email, mobile phones, communication satellite, fiber optic cables, digital cameras, global positioning system, GPS, first man on the moon, first reusable spacecraft, structure of DNA, polio vaccine, birth control pill, heart transplant, MRI scanners, IVF, artificial heart, nuclear power plants, and industrial robots. That is the next 40 years. In the last 35 years, from 1990 to now, the Wi-Fi, Bluetooth, digital cameras, tablet computers, smartphones, search engine, high-speed internet, cloud storage, e-commerce, streaming media, blockchain, voice-over IP, Wikipedia, CRISPR, deep learning, generative AI, quantum computing, virtual reality, electric vehicles, reusable rockets, rovers on Mars, drones, autonomous driving, mRNA vaccine, human genome mapping, prosthetic bionics, targeted cancer therapy, 3D printed organs and tissues, lab grown meat. that is last 35 years. So the pace of innovation has accelerated, and it's going to continue. It's a mistaken belief that these innovations happen because of smart people, individuals with unnatural brilliance. That's what we tend to assume, and that's why we're making these discoveries. But that is not the reason why this happens. There's not been a sudden growth in the number of smart people. The reason we are having this accelerated growth in innovation is because today humans have learned to organize themselves to make such advancements as a matter of routine. It is because we have been able to build institutions that can drive such progress as a matter of routine. It is because these institutions that we have built make science, technology, discovery as their sole aim and recruit people to make progress and yield breakthroughs as a matter of routine. So, सगळे भाशेन सांगता म्हणल्यार संस्था घडयल्यार जातूंतल्यान अशी progress in innovation and breakthroughs जाता. It has nothing to do with smartness and brilliance. So what are these institutions? So these institutions are not filled with some intelligent लोग. There are a few, very useful, very helpful, but mostly they are filled with ordinary people. Ordinary people who know to do their job well, just like any other job. These institutions have do five things. First, they figure out what the next big thing is. Next 5% is what is the next big thing that we need to focus on. Second, allocate money for it. Third, get competent people to do the exploration, discovery, innovation, and organization of knowledge for those problems that we have found that they are important. Fourth, translate those discoveries into products that solve a problem of the day. That's a problem. And fifth, sell those products in the global market, thereby changing human life. Those are 5 things that the institution do. So when I started my career into this after 11, 12 for engineering, after engineering, I started with this simple interest in math. I liked math. I was interested in mathematics. I was lucky enough to get into best institutions, and therefore I had the opportunity to make discoveries and push boundaries. But when I look back at Goa, India, or much of the developing world, what I see missing is not the smart people. There are enough smart people. What I see missing is those institutions. What is missing is not even money. What is missing is the lack of understanding that it is these institutions and not individuals that are responsible for this accelerated growth of innovations. So I read to you this list, right? It's a huge list. You may think everything is done. There's nothing much to be done anymore. So there's Anna. Have you made this much progress? It may seem that way. But that's a folly. It's not true. If you look at it closely, the science and technology progress is going to stay, and it will accelerate further. Because even more number of countries and more people are working towards it. There are more institutions today that are working towards this. So it's going to accelerate further. Just to give a few examples. AI and robotics is going to change the way we live, work, interact, consume information. Consume information probably already is happening. You ask ChatGPT. We have actuated robots, which are like walking dogs, humanoids. Whereas they can move. But now with AI, you're slowly going to have intelligence in them. That's going to create a new set of things, new set of products. Quantum computing. With With quantum computers, there's been a lot of progress in the recent years. And what the important thing is, can do computations very fast that are not possible for the classical computer to do. With quantum computing, you can design new kinds of sensors that have less measurement errors because the sensor sense things at a quantum speed, so it's less noise. It's also been applied in drug discovery because quantum computing helps in modeling together molecular interactions, how two different molecules interact. You can simulate that on a quantum computer much better than you could do it on normal computers. Another thing is quantum key distribution, secrecy, privacy. Synthetic biology, another example. So this is a field that is directed towards engineering cells and living organisms. So living organisms cells naturally exist, but you can edit DNA and now you can engineer cells and living organisms. So potentials are you can design microbes in lab which can eat plastic. So your plastic problem might be solved. You can engineer immune cells that will go and in a targeted way fight cancer in your body. So if you are a teenager, you should join this march. If you are in school, read more about quantum computing and synthetic biology. Figure out what are the questions that scientists are looking into solving. If you are a teen looking for a career, right, in your late 15 to 20 years old, looking for a career, get into AI and robotics. Maybe you can build one. Not because you got or marks or you came first or you got more than your cousin. But do it because these are the most important questions for human civilization. But because these are the most challenging questions that any human being on planet Earth can tackle. And because it is only progress on these that will determine the future of human civilization in the long run. A society, any society, either in the developed world or developing world, should put its people towards solving these challenges. Being poor, coming from not so well-to-do economic background, or from a developing or underdeveloped country, is no excuse for you to put these challenges on the shoulders of others. So my advice for Goa is the same. We should put our attention towards solving these challenges. Let us not ask why Mother has less water for us, but ask how we may advance nanotechnology to desalinate salt water that we are in abundance of. Let us not crib over diminishing size of agricultural land, but ask how we may produce all 82 varieties of Goan mango in tall buildings by indoor farming and serve all 8 billion people in the world with that. And let us not be satisfied with having large human population directed towards menial labor. Let's work towards uplifting them and directing them to cognitively more demanding tasks such as science and technology and automating human labor. And it is possible to do this here in India. If you put that system, those institutions, filled with ordinary people that I talked about. Now let me tell you why Goa among all states, and this will be the last point I make before I stop. Let me tell you why Goa among all states in the Indian Union is the right place to invest in science and technology. First, Goa is the highest per capita income state in the country. Highest per capita income, highest per capita GDP state should go after the best thing that is out there. The science and technology and innovation is the best thing that is out there. So we should be going after it. Second, highest per capita state also means that your children are aspiring for better careers. Better careers than anywhere in the rest of India. So I met a taxi driver who told me that his daughter graduated in science, and she's now moving to Bangalore for postgraduate studies and job, because she's interested in science. And his lament was that there's nothing for her here. Invest in science and all better or educated Goans will stay in Goa. Third, Goa has a migration problem. And Goa will continue to have a migration problem. More than 50% of Goans today, you may classify them as outsiders or first generation Goans. As you tackle it, you should realize that your choice today is not whether you will have migrants or not. Your choice today is what kind of migrants you have. Invest in science and technology and you will attract the best from all states in India. Continue to focus on tourism and agriculture and you will attract the best. Fourth, urban-rural divide. Urban-rural divide is going to plague is bound to plague other states. So, for example, you heard we had recently Kannada agitation in this Bangalore. Right? So, the more Bangalore grows, the rest of the Karnataka population feels alienated. Goa has a small population. If you do this right, you can uplift all Goans fairly quickly so that alienation doesn't exist. So challenges won't exist, it's less than what exists in other states. Fifth, Goa has better cultural sensibilities than other states that can be moved towards doing science. We can call this a personal bias, but historically there has been less to no issue of political violence or religious strikes. Sixth, Goa already has a good set of institutions to start from. They are not where we want them to be, but they are there. We will only need an infusion of talent, some culture, and capital. So my proposition to you is that you should make that investment. India will have to start somewhere. Goa is the best place for it. So long time ago, I had an interview in IISc Bangalore. This was a program that I didn't finally decide to join, but it was a joint PhD program between the mathematics department, and neuroscience department. And I didn't know much biology, but they asked me a question. There's some algae in the sunlight in a pond, and so the question basically was whether that algae will die or grow, and if it dies or grows, at what rate it will grow or die. And at that point, something occurred to me. That all forms of human life, population, or even animal life, extinction, aspiration in our minds to spread of viruses like COVID, and rumors on social media, they either grow exponentially or die exponentially. Nothing stays the same, ever. For Goa, you have to decide whether you want to aim and chart a path of high exponential growth or die. It is never supposed to be the same. Invest in science, push your people to do science and technology, and you will be charting the future. For the invitation, I want to thank Salil Kare, Prasad Pende, and the rest of the development committee. I also would like to thank all the organizers of Vichaar series. I hope you consider this question seriously. I'll stop here. And